You know, there are some math rules that you just learn, but they never feel quite right, do they? Well, today we're tackling one of the most famous ones. Why a negative times a negative somehow equals a positive. I mean, we all learned this in school, right? We memorized it for the test, but did you ever really stop and ask, why? How is it possible that two negatives, these two wrongs, actually make a right in the world of mathematics? Look, I get it. It feels totally backward. But stick with me here because you're about to see that this isn't just some random rule they made up. It's a conclusion that absolutely has to be true for math to make any sense at all. To crack this puzzle, we've got to first get reacquainted with our main characters in this story, the integers. So, unlike the numbers you first learned to count with, 1, 2, 3, integers add a whole new dimension. They don't just tell us how many, they also tell us which way from 0. And this is where it all starts to click, because you see these things everywhere. Think of it like this. A positive number is a gain, like money in your pocket. A negative is a debt. Positive is moving forward, negative is hitting reverse. Integers are basically the language we use to describe all these opposites in our daily lives. All right, let's start digging into this mystery. And we're going to start with a rule that feels a little more, well, normal. We'll use a classic tool to help us out, the number line. You know, a really simple way to think about multiplication is just as repeated addition, or you could think of it as a series of identical jumps. The first number tells us how many jumps to take, and the second one tells us the size and direction of each jump. So, for 3 times -2, we start at 0 like always. The first number, 3, tells us to get ready for 3 jumps. And the second, -2, tells us each jump is going to be 2 steps backward. So, 1 jump to -2, a second jump to -4, and a third lands us right on -6. See, it makes perfect visual sense. Okay, so far, so good. A positive number of jumps in a negative direction lands you in negative territory. The number line proves it, and it feels right. But this doesn't actually solve our big mystery, does it? I mean, what even is a negative number of jumps? It's confusing, right? The number line model kind of falls apart here. So let's switch gears. We're going to use a tool that's way more powerful, the simple, inescapable logic of patterns. You know, one of the most beautiful things about math is that it has to be consistent. It has to follow its own rules. So if we find a logical pattern, that pattern has to continue, no matter where it leads us. So let's build one and just see what happens. Okay, look closely at this. We're keeping the times -3 part the same, but on the left, we're just going to walk the first number down by 1 each time. 2, 1, 0. Now, watch what happens to the result on the right. To get from -6 to -3, what did we do? We added 3. To get from -3 to 0, we added 3 again. See the pattern? It's a steady climb, adding 3 every single step. So, if we want to keep this perfect, beautiful pattern going, what has to come next? When we take that final step down from 0 to -1, what must the answer be? It's gotta be +3. It's the only answer that works. It's the only number that keeps the pattern alive. You add 3 to 0, you get 3. The logic holds up. And there it is. That's the reason. A negative times a negative has to be a positive. Not because a teacher said so, but because any other answer would literally break the fundamental consistency of math. It's a logical necessity. Okay, that's cool, the pattern works. But so what? Is this actually useful? Oh yeah. This rule is absolutely essential because it perfectly describes how the real world actually works. And you really do see this logic all over the place. Think about your finances for a second. Let's say you remove a $50 debt. Well, removing is a negative action, and the debt is a negative value. What happens to your net worth? It goes up by $50. It's a positive gain. It's not just an abstract idea, it's literally how money works. And that's why getting the sign right is, well, it's everything. It is the difference between making a profit and taking a loss, between an engine pushing forward or going in reverse. This rule isn't just for tests, it's absolutely critical for accuracy in science, engineering, and finance. So at the end of the day, understanding this little rule isn't just about passing a math class. It's about appreciating that mathematics is this incredible, consistent, logical system that we can rely on to make sense of a complex world. And, you know, that's a pretty positive thought.